So here's an example problem. It says produce a cumulative frequency curve. You know what that is, curves that look something like that. For the given frequency distribution, so given a frequency distribution table, well, the first two columns anyway, and then we're then asked to determine the percentiles that correspond to each upper class boundary. Essentially, we need to find the percentiles at which the upper class boundaries lie. The table shows the number of titles won by a group of 31 professional boxers. So what we're saying is, these class intervals represent the number of titles won by boxers. We have 31 boxers, so the total frequency must be 31. So if I ask the question, how many boxers have won between 0 and 2 titles? The answer is 3. How many boxers have won between 3 and 5 titles? So I mean boxers as in professional boxers that fight. How many boxers have won between 3 and 5 titles? 7. How many boxers have won between 6 and 8 titles? 12. How many boxers have won between 9 and 11 titles? 8. And how many boxers have won between 12 and 14 titles? Just one of them. So there's only one guy that's won between 12 and 14 titles. So that one guy has won the most titles out of the 31 boxers. Because a cumulative frequency curve is being produced, we need to ensure that there are no gaps between consecutive upper and lower class limits. Observing the upper class limit of the first class and the lower class limit of the second class shows that there's a gap. Think about it, there's a 2 and a 3. To resolve the gap, two limits just meet in the middle. So 2 goes to 2.5, i.e. 2.5 is the upper class boundary of the first class interval. If you consider the upper class limit of the second class interval and the lower class limit of the third class interval, you find that they have a gap of 1. So we have 5 and 6. It's a gap of 1, so they meet in the middle. So 5 goes to 5.5, which means that the upper class boundary of the second class interval is 5.5. What we've done so far is split the gap between consecutive upper and lower class limits into 2 parts. And then we've obtained the upper class boundaries by adding 0.5 to each upper class limit. So 0.5 plus 8 gives 8.5, 0.5 plus 11 gives 11.5, and 0.5 plus 14 gives 14.5. So we have our upper class boundaries. We need the cumulative frequencies, and once we have that, we can plot the cumulative frequency against the upper class boundaries, the modified ones, to obtain our cumulative frequency curve. So as at this upper class boundary, the cumulative frequency is going to be frequency here, which is 3. Cumulative frequency as at the next upper class boundary is going to be 3 plus 7, which gives 10. Cumulative frequency here is going to be 10 plus 12, which is going to be 22. Cumulative frequency here is going to be 22 plus 8, which is going to be 30. Write that neatly. The cumulative frequency here is going to be 30 plus 1. So that's, I'll just remove the arrows and write it out without crossing our upper class boundaries. So 10, 22, 30, and 31. This is 30, by the way. Let's do it neatly. 30, 31. So I'm going to plot the cumulative frequency curve. But before I do that, I'd also like to just make you observe that I have a percentile column here, and I'm going to use that to state the percentile at which the upper class boundary of the class lies, but we'll come to that later. Let's plot the cumulative frequency curve. So these are the points we need to plot. 2.5 against, so this is what we have here. So I'll just write out the points on the right hand side. 2.5 and 3, where essentially x coordinate is the class mark, in this case the upper class boundary. What I meant was the x coordinate is a mark, but we're plotting the upper class boundary. And the y coordinate is going to be the cumulative frequency that corresponds to that upper class boundary. So the next point we have is 10, 5.5. Next point we have is 22, and so it should be 5.5 and 10 because 5.5 represents the mark while 10 represents the cumulative frequency, which is going to be the y coordinate. So next one, sorry, is 8.5, 22. Next point is going to have coordinates 11.5 and 30. 11.5 is an upper class boundary and 30 is the cumulative frequency corresponding to that upper class boundary. And finally, 14.5 and 31. So vertical axis is going to be the cumulative, which I'm just going to shorten as cum fric, and the horizontal axis is going to be, well, we're going to plot the upper class boundaries, but I'm just going to write class marks. So 2.5 and 3 is what we want to plot, so we just need to ensure we calibrate the axis to contain all the cumulative frequencies, so something from 3 to 31. I'll do that now. So I'll just have a 10 here, 20 here, and 30 here, and maybe just have 40 as well. 31 will be somewhere here. And then for the upper class boundaries, we need to be able to go from 2.5 to 14.5. This time I'm just going to start from here, so 2.5. I need to get up to 14.5. So I'm going to use intervals of 3. So 2.5, 5.5. Need to reduce the brush size. 5.5, 8.5, 11.5, and another 3 gives 14.5. So I'll just use an interval of 3 between consecutive points. Essentially, what I've done is I've said let an interval of 3 represent 3 units of the marks. An interval of 3 represents 3 units of the marks. So an interval of 3 represents 3 units of the marks. That's what I've used. But don't worry about that. Now we have a calibrated horizontal axis, and we just need to plot our points. So the point 2.5 and 3 is going to be somewhere here. It's somewhere here. Point 5.5 and 10, somewhere here. Point 8.5 and 22. It's going to be somewhere here. The point 11.5 and 30, 11.5 and 30, somewhere here. And finally the point 14.5 and 31. 31 is just going to lie slightly above 30. So somewhere, let's say somewhere here. I'm now going to join up all the points. If you're doing this at home, you should be plotting it accurately, and you should use a French curve to join up the points to give me this cumulative, I missed that point, cumulative frequency curve. So that's the cumulative frequency curve. I'm now required to determine the percentiles corresponding to each upper class boundary, which is essentially a mark. Now to determine the percentiles for each upper class boundary, let's start with this upper class boundary of 2.5. Remember, we're talking about the number of titles won by certain boxers, and we put them into intervals. The cumulative frequency of 3 corresponding to this upper class boundary tells you that there are 3 occurrences that fall into this interval. So to put this into context, there are 3 boxers that have won titles between 0 and 2 in number. Let's move on to the next upper class boundary. 10 is the cumulative frequency that corresponds to it, and this 10 tells you that there are 10 boxers that have won titles, well, that have won titles that are less than or equal to 5.5 in number. So boxers have won titles that are between 0 and 5 in this case, but based on this upper class boundary less than or equal to 5.5. 31 tells you that there are 31 boxes that have won titles that are less than or equal to 4.5 in number. So percentile for this upper class boundary, let's see. It's given by the cumulative frequency of that upper class boundary divided by the total frequency multiplied by 100. So for this upper class boundary of 2.5, the cumulative frequency is 3 divided by the total frequency. If you add it up, you find that's 31 multiplied by 100 to give 9.7, or we could say approximately 10. So 10th percentile. If I do the same thing for the other upper class boundary, so 10 divided by 31 by 100 times 100, I'll get that this number of titles, this mark here, lies at the 32nd percentile. I'll do the same thing here for this upper class boundary. So 22 divided by the total frequency 31 times 100, I'll get the 71st percentile. Same thing for this upper class boundary. 30, the cumulative frequency, divided by the total frequency times 100, and I'll get approximately the 97th percentile. And do the same thing for this upper class boundary of 14.5 will give the 100th percentile. What does this mean? It means that 10% of the boxers have obtained or won titles that are less than or equal to 2.5. Essentially, 10% of the boxers have won at most 2.5 titles. 32% of the boxers have won at most 5.5 titles. 71% of the boxers have won at most 8.5 titles. 97% of the boxers have won at most 11.5 titles. 100% of the boxers have won at most 14.5 titles. If you're anything like me, you probably don't like cramming formulas unnecessarily. And this is one of these cases where you don't need to remember the formula I just put down. Now, you want to find the percentile corresponding to this mark or this number of titles. This is the question you ask yourself. What percentage of all the people, what percentage of the population, what percentage of all the boxers have at most 2.5 titles? So what percentage of the population have less than or equal to 2.5 titles? Well, 3, the cumulative frequency 3, out of the 31 people. Convert this fraction to percentage and multiply it by 100 and you get approximately 10, which gives 10% of the population have won at most 2.5 titles, and that means that 2.5 titles lies at the 10th percentile because 10% of the population have won at most 2.5 titles. To determine the percentile for an upper class boundary of 5.5 titles, you have to ask yourself, how many people have won at most 5.5 titles? So i.e. less than or equal to 5.5. Well, that's what this cumulative frequency of 10 tells you. It tells you that 10 boxers have won at most 5.5 titles. So 10 out of the 31 boxers have won at most 5.5 titles. Multiply this by 100 to give you this as a percentage, and tells you that approximately 32% of the boxers have won at most 5.5 titles. That means this mark here, or this number of titles, 5.5, lies at the 32nd percentile. Remember, if a mark is such that X% of the people obtain at most that mark, then that mark lies at the Xth percentile. So since 32% of the boxers won at most 5.5 titles, that means this mark 5.5, or this number of titles 5.5, lies at the 32nd percentile. So doing the same thing for, I'll just do one more example, 11.5. for this number of titles, we know that at most 30 people, no, 30 people have one, at most 11.5 titles. 30 out of the 31 people. Converting this to a fraction gives, and to a percentage gives approximately 97%. That means 97% of all the boxes have one, at most 11.5 titles. That means 11.5 titles lies at the 97th percentile. 97%, 97th percentile. So that's the approach if you don't want to use a formula. Here's an example that essentially summarizes all the questions that you are likely to face that relate to the cumulative frequency or cumulative frequency curves or quartiles or percentiles. Or to put it differently, this question summarizes all the concepts that I expect you to understand after watching this video. So that's sort of a disclaimer, but to be honest, it should cover pretty much everything you need to know about cumulative frequencies as at this point of producing the video. So it says the marks of 50 candidates of an exam are summarized in the frequency distribution table below. So here's one of the groups. It's a class, there's another class, another class, another class, and these are the class intervals. For the first class, scores between 0 and 19 lie in it, and there are 6 occurrences of scores in this interval, which means that 6 people have a score that's between 0 and 19, which is pretty poor. Here we also have 6 people having a score between 80 and 99 marks in the exam. The first question asks for the production of a frequency distribution table. The next one asks, which you know how to do. Next question says produce a cumulative frequency curve. So that's the next problem. The next problem says determine the median mark. Essentially you need to find Q2. We've covered that. Next says find the interquartile range. Next says find the semi-interquartile range. Then the next question says if the pass mark is 60, what percentage of students passed? Next one says or ask if a student is chosen at random, what is the probability that his or her score is less than 79? And we need to use the curve and the table. If a student is chosen at random, what is the probability that his or her score is at least 60? Now in this case we probably won't need to use the curve, but I'll try and demonstrate the use of the curve. But let's start with the first question. Produce a cumulative frequency distribution table. So I have this table here, the same class intervals, the same frequencies. Because a cumulative frequency curve is going to be produced, I'm going to determine the upper class boundaries. Let's determine the cumulative frequency. So at this stage, cumulative frequency is 6. The next one is given by 6 plus 2, which is 8. The next one is given by 8 plus 12, which is 20. Next one is 20 plus 24, which is 44. Next one is 44 plus 6, which is 50. So that's 44, by the way. So I could rewrite it. This is 44. And I should just get rid of this. So we have our cumulative frequency distribution table. So the first question has been answered. Next one says produce the cumulative frequency curve. Because of the gaps, between 19 and 20, there's a gap of 1 unit. Between 39 and 40, same 1 unit. So I'm just going to modify the upper class limit. So 19 becomes 19.5, 39 becomes 39.5. The upper class limit of 59 is extended to 59.5. The upper class limit of 79 is extended to 79.5. 99 extended to 99.5. So essentially what we're going to plot is, well, the cumulative frequency has the y coordinate and the modified upper class boundary as the x coordinate. So these are the points you're going to plot. 19.5 and 6, 39.5 and 8, 59.5 and 20, 79.5 and 44, and then 99.5 which corresponds to a cumulative frequency of 50. So we need to plot these 5 points. This is 1 point, this is another, this is another, this is another. You need to plot all of them and join them up to give a cumulative frequency curve. So that's what I'm going to do. First, I'm going to calibrate my axis so that all these values can be located. So here I go. 10, 20, 30, 40, 50. I'm just gonna write this representing the cumulative frequencies. Here we have class marks. Just gonna move a bit. So I need to go from 19.5 to 9.5. So I'll just use an interval of, well, my first point to start somewhere here, 19.5. I could use a squiggly line. Essentially what is being done is that the axis is being, well, just ignoring the points that will have been in this region, just starting from my desired point, 19.5. I'm going to use an interval of 20, so the next mark is going to be 39.5, the next mark is going to be 59.5, 79.5, 99.5. So I'm going to approximately plot points. So 90.56 is going to be somewhere here. 39.58. So I plotted this point. 39.5 and 8. It's going to be somewhere here. 59.5 and 20. 79.5 and 44. 44 is going to be somewhere here. And 99.5 and 50. So this is the cumulative frequency curve. There you have it. Simple stuff. So to determine the median mark, we need to determine the mark that lies in position Q2. So what I did was I just put the questions right above here. So we've answered this. Median mark Q2. That's the mark that lies in the, well, in this position. Now what's n? The total frequency. And from what we have here, our total frequency is 50. 6 plus 12, 8, 8 plus 12, 20, 20 plus 24, 44, 44 plus 6 is 50. So the median mark lies in this position, which is the 25th or 25 plus point, well, 25.5 position, if you could say that. So this position anyway. So we have to go to the cumulative frequency curve, locate 25.5 and read off the corresponding mark. 25.5 is somewhere here, so horizontal line to the cumulative frequency curve and down here to the class mark to obtain Q2. So Q2 is going to be something like 62. I'm just roughly estimating that, so we're just going to work with that. I would like you to plot this at home and obtain the actual score, but it's obviously going to be somewhere between 59.5 and 79.5. So I'm just estimating it as 62. Estimate. Right? You need to determine it accurately. So now that Q2 is known, solve this question. To determine the interquartile range, we need to know Q3 and we need to know Q1. So Q3, how do you get Q3? You need to determine the mark that is in this position. For Q1, you need to determine the mark that is in this position. Given that n is 50, so 3 over 4 times 51 is 38.25. So we need to find the score that's in this position, and we also need to find the mark that is in this position. 51 over 4 is 12.75. So Q3 from our cumulative frequency curve is a score, I'll use a different color, that lies in the 38.2, well, in the position 38.25 is what we need to find on the cumulative frequency curve, which will be somewhere here. You need to locate that accurately, and read off the corresponding mark, which is going to be somewhere here closer to 79.5. So I'm just going to guess, roughly estimate that Q3 is, I'll just call it 72. Just call it 72. And for Q1, we need to determine the score that is, well, corresponds to a cumulative frequency of 12.75. So 12.7, this position, 12.75 is going to be somewhere here. So let's go around about here, which is going to be about, let's call it 42. So I'm going to call Q2 42. So we have Q2 here. You need to determine the value accurately at home, and the score here is Q3. So for an interquartile range based on my number estimates, the interquartile range is going to be Q3 minus Q2, which is going to be 72 minus 42, which is going to be 30 marks. Because we're talking about marks. Or just say 30 anyway, because I didn't really give units for the marks. Well, 30 marks, let's put it that way. For the semi-interquartile range, what this next question asks, you know that that's going to be interquartile range divided by 2, which is going to be, well, around space 30 divided by 2, which is 15. So 15 marks. So what we've done so far, this and this. So we've answered this question, this and this. Next one, question 6 says, if the pass mark is 60, so 60 is the pass mark, what percentage of students passed? I can use this table or the original table. Let me use the original table. The pass mark is 60. How many students passed? How many students got marks that are greater than or equal to 60? Right? Well, 24 students got marks between 60 and 79, and 6 students got marks between 80 and 99. So that means 24 plus 6, 30 students passed. But we're asking the percentage of students that passed. So 30 students passed out of how many students in total? 50. As a percentage, that's 30 over 50 times 100, which is 3 over 5 times 100. 5 here, 1, 500. 23 times 20, 60. So 60% of the students passed. So we're done. So here are the last two questions. The seventh one is as follows. It says, if a student is chosen at random, what is the probability that his or her score is less than 79? And you can use a curve and a table, or both, or one of the two. So the curve and the table, the curve or the table, or both. Anyway, I'm going to change this question to less than or equal to 79. So I'll just put that there, or equal to. So let's find the probability that a student chosen at random obtains a score that's less than or equal to 79. Now, if I use the original class intervals, I'll know that 79 is the upper class boundary of this class, and the number of students that have scores that are less than or equal to 79 is going to be 44. So the probability that a student chosen at random scores less than or equal to 79 is given by 44 divided by the total number of students, which is 50. So it's essentially saying the number of ways, or the number of occurrences of the desired event, which is scoring less than 79, less than or equal to 79, divided by the total number of occurrences, so 50, which is the total frequency. So that will be the answer to this. If one wanted to use the cumulative frequency curve, just draw a new one. So we have cumulative frequency on this axis, and class marks on this axis. For curves, something like this, all you have to do is, well, in this case, all you have to do is go to 79 on the cumulative frequency curve. So you locate 79 maybe somewhere here. 79 is a mark, so we're reading 79 off the class marks, and you find the corresponding cumulative frequency. And you read off that value. Whatever you get is going to be the number of students that scored less than or equal to 79. And it's going to be something, it's going to be approximately 44. Why do I say approximately? Because we plot the cumulative frequency curve was plotted by using the upper class boundaries. So we actually changed what we were given in the original table, but what you get is something that's approximately 44 as the number of students that scored less than or equal to 79. For the probability, you have to divide that by the total number of students, total number of occurrences, the total frequency. So the final question is as follows. It says, if a student is chosen at random, what is the probability that his or her score is at least 60? That means 60 is the least score we're considering, so the score must be greater than or equal to 60. Now if I use the table and I use the original class intervals, scores that are greater than or equal to 60 fall into these two classes. This one here is for scores between 60 and 79, and this class here is for scores between 80 and 99. So we know that 30 students obtained scores that are greater than or equal to 60, 30 out of the 50 students. So the number of desired occurrences divided by the total number of occurrences of scores. So 30 divided by 50, which is simply 3/5.